Hello, and thank you for joining today's seminar. My name is Guy Guzner, and I'm the CEO and co-founder of Fireglass. And today we're going to talk about the 5 reasons why your web gateway is falling behind in protecting against malware and phishing attacks. On today's webcast, we're going to talk about, just a second, what are the 5 reasons your web gateway is falling behind, talking about the lack of innovation in the market of security gateways. And then we're going to talk about a new technology coming from Fireglass that introduces the concept of isolation that is going to solve this problem. And we'll do a live demo showing this technologies, talking about common use case for isolation, and then finally talking about and doing some question and answers. So let's start with the reason why URL filtering is failing. The first reason is that URL filtering is based on the concept of detection, and that's about classifying websites. And the idea of classifying is that you need to go to websites, you need to analyze that website and see what's going on in this website. And there are several methods to doing this kind of analysis, doing content analysis, using reputation services, using sandboxing, trying to see if anything goes with the website. But the basic fact is that you first need to visit that website and analyze it. The problem with this approach is that it's reactive, is that by definition, classification is always behind the curve because you need to see that website first. And in the reality is that there are many websites that are created every day. In fact, there are 571 websites that are created every second, and the attackers are using this in order to create new websites all the time. So the security vendors have hard trying to keep up with these new websites, these new domains, and practically when they are doing their analysis of the website, it's already too late because most of these websites will be, and most of these domains will be used only a single time for an attack, and then the attackers will move on and use another domain. So by the time there is the opportunity to analyze these websites and determine that this is malicious, it's no longer used. The recent study shows that 71% of the unique host names that are being created are only used for 24 hours. So obviously the method of classification doesn't work. This brings another problem, because you can say that, okay, what if I just block access to everything that is not uncategorized by the secure web gateway, then I'm protected. And in fact, many organizations are using this type of approach to protect against malware and different attacks. But the problem with this approach is that it impacts productivity, because in the reality, most of the websites are not malicious. These are legitimate websites that are new and still didn't gain enough traffic in order to be analyzed by the security vendors. And this introduces a problem of productivity. A lot of organizations have to maintain change management and to require people to go through the help desk in order to allow access to these uncategorized websites. This creates an operational overhead. They have people who are tasked with the job of looking at these websites, analyzing them, and then deciding on whether to allow them or not. And this creates very long policies that are very hard to maintain, and they just keep growing, because normally these exceptions are never removed. So as this continues, it gets more and more complicated. So also this approach of just trying to block the things that are uncategorized and are unknown also doesn't prove itself. So if we move on to the next problem, it's also, even if we think that we were able to categorize the websites that the users are going to, there is a big question whether this categorization is really good enough, and whether this website is truly safe. When security vendors are scanning and classifying this website, they usually do this at periodic timetables, and then make a decision. But the reality that the content in the web is dynamic. A lot of the websites are serving content from third parties. Content is being syndicated from different vendors. When you go to a single website, content can be coming from different domains. For example, advertisement. And it has been known recently that many of the attacks on very popular websites were coming from content that wasn't originating in this on this website. It was coming through malicious advertisement, something called as malvertising. So even at a given point this website was really safe, it doesn't mean that in any point in the future this website will continue to be safe. The other problem is that when threat actors are performing targeted attacks against specific targets, and will use these types of malicious website, they will make sure that the attack will not be triggered by the security vendor's scanning mechanism. In fact, some of these attackers, they maintain lists of IP addresses and sources where these scanners are coming from, and if any request is coming from this type of IP address, then they will not initiate any kind of exploitation. Finally, because websites are being maintained dynamically, and they're using content management solutions, then they become an easy target, because once a vulnerability is found with one of these management solutions like WordPress and Drupal, these sites can become vulnerable, even though that in the past they weren't. And there were several examples. For example, just last July, 10,000 of websites that were using a vulnerable WordPress and Joomla content management services were hacked and changed in order to serve malware. Another very famous attack was with the Forbes website in the end of 2015, where the thought of the day widget of the Forbes website was modified in order to serve malware, and it was done only for specific users that were going for this website. So this attack was going for a long time without really anyone knowing about it. So in summary, even if a website was classified safe at some point, you can never know that this is the situation going forward. The next reason is that websites are not using just drive-by infections and malicious web content in order to infect people with malware. Another very common attack vector is also to use files, things like PDF documents, Office, and so on, that are being downloaded from these websites in order to introduce malware. The problem with this approach is that what the web gateways are normally doing is that they're integrating standard antivirus scanning products into their gateways, or they use sandboxes. And the limitation is that antivirus by itself is something reactive, much like the URL filtering. The AVs are relying on signatures or some heuristics that are no longer effective. And the attackers, the same way that they change the URLs, that they also change the files that are being served by this website. They are creating targeted files that are specific for each one of the campaigns. And when the AV vendors have the chance to analyze them, it's already too late, because the website will be serving new variants of the malware that has a different signature. When using techniques like sandboxing, there are other limitations. By definition, sandboxing is the attempt to detonate malicious content within a sandbox environment and then see if anything bad going on. And this is something that takes time. And for the dynamic way of the web, it's not something that is really effective for prevention, because it's not really realistic to ask users to wait for, and something it could even take a few long minutes until this analysis is complete. So these solutions are effective only if you're trying to do something which is called second-time prevention, meaning that the first time the file will pass through the system, the detection will only happen afterwards, and then the next time this file is passed, then it will be blocked. But because the attackers are continually changing the files and they're using files with different signatures, this method is not effective. Also, advanced attackers are become aware of the sandboxes that are being used, and they design their malware in a way that it can detect that it's running within this sandbox environment, and then it will use all kinds of evasion techniques in order not to display any kind of malicious behavior, and then this file will be considered as safe by the sandbox, but then when it gets to the actual target, it will detonate its malicious payload. So this approach is not effective as well. Finally, if we think about attacks and about what web gateways and proxies are doing, is that once an attack is already going on, most of the malware attacks require some kind of communication by the malware controller to a command and control center in order to provide instructions for the malware what to do in order to exfiltrate data, in order to download other malicious payload. Web gateways are trying to analyze this traffic and try to detect whether the communication is a legitimate web communication or it's a malware command and control. But once again, the attackers have the ability to learn this type of defenses and find ways around them. Malware has become very good in mimicking the behavior of legitimate browser traffic. So if you look at this command and control traffic on the network layer, it would look like traffic coming from a regular browser with legitimate headers and format, and it would look like just the user was going to some website. The visibility that is available for these gateways on the network level doesn't really differentiate between a human user that goes and open a browser and try to go to a website, than something that is automated, some kind of bot that is generating traffic that looks the same on the network level. So any visibility of what if was the actual user interaction with the web is missing with what the proxies are able to do, and therefore they're not able to distinguish between human-generated traffic and bot-generated traffic. Another technique that malware is using is that it's using well-known sites for its command and control. So this command and control doesn't necessarily has to be some kind of website that was created for this purpose, and then maybe it's easy to detect and block traffic to this website. They can be using general purpose websites that allows users to post content and to share content in order to facilitate the communication between the attacker and the malware. For example, there was a malware that was using Gmail in order to do this kind of a communication. The malware was creating Gmail drafts, and which look totally legitimate on the network. And by reading these emails, it was able to gain its commands and return data to its controller. A recent study was showing that 80% of the leading secure web gateways do not block the latest malware communication when it's trying to contact command and control centers or to exfiltrate data. This malware has been done by SecuAlert, and it's something that is very interesting to see and to check out. So far we covered what are the main reasons why these current approaches of secure web gateways are not working and how attackers find ways around them. Now, let's talk about why this happens, and it really doesn't come as a big surprise if we take a look at the current status of the web security market. What we're seeing here is the magic quadrant for the secure web gateway market for the last 4 years, and this trend even goes back further. And we're seeing that in this quadrant, the visionary space is remaining vacant. We're seeing the same kind of vendors. We see a small amount of leaders, but these are the same vendors doing the same products, using the same approaches that they've been using for years, using the same URL filtering capabilities that were not designed in order to address modern malware, and nobody is really doing any kind of innovation in this market. This is up until now. With Fireglass, we are offering a new approach to web security, which is based on a new concept of isolation. And the first thing important about isolation is the assumption that trying to tell good from bad, trying to detect whether a website or a file or some kind of content coming through is bad doesn't work. So the approach for Fireglass is to isolate endpoints from the internet and to make sure that none of this content gets to execute on the endpoint. So how does it work? Fireglass serves as a barrier between the users and the internet. All of the content that is coming from the internet, it could be web content in the form of JavaScript, HTML, Flash components, all these things that are being exploited all the time, or through documents and emails, are being downloaded and executed within a dedicated secure container. Now, if there's anything malicious within this content, it's going to detonate within that container. And even when it detonates and the attack is somehow successful, and we even anticipate that some of the attacks will be successful, they're only successful in getting into that container. And this is like breaking into a jail. The attackers don't have any access to the endpoints, no access to the internal network, and by design, the way that Fireglass works is that these containers are completely disposable, meaning when you start a new session, we will fire up a new container, But as soon as this session is terminated, we will delete this container and any changes that were made in that container. So even if the attack was successful somehow, there's no possibility for it to stay persistent. What we are doing is that we're taking the visual results of this execution, and because in the end this is what the end user are expecting to see on the screen, and we're sending them using a proprietary protocol that we created for this purpose, so they can see it on their screen as if they were browsing the internet directly, and they're not even aware that Fireglass is running behind the scene. The way that Fireglass is performing it is without requiring any endpoint agent. So you don't need to install any client or anything. The only thing that the Fireglass requires is that traffic will go through the isolation solution, either by working as a standalone proxy or by integrating into proxies that already exist in the organization and just forward the traffic through Fireglass. Also, the deployment is very flexible, and it could be done either as an on-prem virtual appliance or also be consumed as a cloud service. And it allows the users to use any browser from any device and just keep themselves isolated from the dangers of the internet. Now, in order to demonstrate how this works, let's move to a demo. So I'm going to step out of the presentation here and share my screen with you and show you how it works. So let's start with a very basic demo of how things look first without Fireglass. So I'm using here a regular browser, and I'm going to do a very simple search in Google. I'm searching here for CNN, and what we see here is the visual results of the web query that I did. So we're seeing here the search results coming from Google. The interesting part in this is to see what the browser really had to execute in order to view this web page. So if I go and I open the developer tools and I'm doing the view source for this website, we're seeing that my browser is executing a lot of code here, and we're seeing that there's a lot of JavaScript code. I'm just keep scrolling through this page, and this is the attack surface of the web. Every time that I browse to a new website, I'm being served by this code, by different resources, and this is where exploits can be found, and it's very hard really to tell what's going on here, and it's very easy for the attackers to hide their malicious content within this web page, as we talked before. Another example of this situation is if I go, for example, to the Wired web page, and I do the view source over here, we can see that I went to Wired, but there is content that is coming from many different other domains that I'm not necessarily aware of, and that's one of the problems that we were talking about, that the content is dynamic, it's being syndicated from different domains. I don't necessarily know where all the content that my browser is displaying is coming from. So this is the reality without Fireglass. Now I'm going to move and show you how this looks with Fireglass. So what we have here is the same browser. The only difference is that this browser is configured to use Fireglass as its proxy. So we're now seeing the same web page, but I am going through Fireglass, and I'm going to do the same search. And what we're seeing here is completely identical to what we've seen before, because visually this is identical. This is the rendered results of the Google websites that were sent to my browser. But if I want to look and see
what my browser was executing in order to display this web page. So I go again into the developer tools, and I'm doing the view source. What we'll see here is completely different. The first thing that is visible, that we have here a very short piece of code compared to what we've seen before. And what's interesting here is that this code is coming from Fireglass. It doesn't come from Google. So what we did here is that we've intercepted the request to Google, and we replaced this with our code. And now this is the only thing that is running in my browser. So there is no third-party code. There are no third-party resources, Flash components, images, or any other things. There's only content that is generated by Fireglass, and it's 100% safe. But for me as a user, I'm really free to do whatever I was doing before and click wherever or wherever I like. So if I go and I open another web page and I go to CNN, I can go to the CNN web page. I can see the news here. But if again I want to take a look on how and what the browser is doing in order to display this web page, and I do the view source again, we're seeing the same thing. So regardless of what I'm doing and regardless of where I'm going to, I'm always staying within the isolated environment. Nothing reaches my endpoint, and therefore I'm not exposed to any risk. So this is covering the web attack vector that we were talking about. Now, let's see how we handle files, because that's also one of the problems that get passed through the security gateways. So I'm going to show here a typical example of a phishing attack that uses files. I'm going to go into a webmail, and here in this webmail we have a phishing attack that we created for this purpose. So if I click on this email, I get here a typical phishing attack, someone that appears to be looking for a colleague. There is an attachment here for some financial results. So clicking on this attachment to see what's going on here. And what we're seeing that instead of downloading this file locally to my computer, and instead of running, and in this case it's an Excel file, look at it locally and be open to attack, I get here an Excel file that is fully functional, that I can interact with it, that I can work with it. But again, if none of this execution is happening on my computer, if I go here again and I do the view source, you can still say that even that I'm working with a file, I'm still staying within the isolated environment. Now, Fireglass allows defining a workflow that will take this file and will pass it through several security mechanisms while I'm still interacting and viewing the file before we let the user download that file. And this includes scanning it against several reputation systems in the internet, going through sandboxing solutions, and finally doing content disarming, which means that we're able to take this file and reconstruct it from scratch. So if there's any malicious content, any malware, it's going to be completely lost within this transformation, and then the user is able to download a clean version of this file. In this case, because this is a malicious file here, and I attempted to download this file, you can see that this download was blocked because we were in the background checking it with several mechanisms, and we found that it was malicious by VirusTotal, so we don't allow downloading these files. So we have total control of the user experience here. We can allow users interact with the files. We can allow them to see and view the files, but to do it in a safe way, and only allow download copies when something is really considered safe. Another nice thing that you can do with Fireglass that is not possible with other secure web gateways is also inspect and control files that are protected by a password. So here I have another example, and in this case, someone sent me a file that is protected by a password. So normally, the decisions that you need to make with a regular secure web gateway is whether to allow these files with no inspection, and then you open yourself to risk, or to block this type of files, and then you end up with an operational problem. So here, if I try to download the file, you will see that we first downloaded the file to our container. We see here our download manager, so nothing was sent to the end user yet, nothing was downloaded yet, and we detected that this is a password-protected file. So we're able to prompt the user for the password, decrypt the file, and then see if this is something that should be allowed or not, so we don't lose any of the security. And you see that now that after I open the file, the download is alight. So we don't lose any of the security, even with password-protected protected files. That shows you the value of isolation and how all of web activity, email activity, opening files is done in a truly isolated way without using any type of client, and giving the administrator the control of what is the user allowed and not allowed to do. I want to show you also the administration console for Fireglass, and to see the flexibility and our enterprise features that allows you to control of that. So if I go to our administration console, you can see that everything is controlled by a policy, and this policy is very similar to what you see in regular secure web gateways. So Fireglass has all the capabilities that you have in a regular web gateway. It has the ability to identify users using Active Directory and employ policy according to the groups. You can create rules that are based on the source, the destination of the user, and we have also the same categorization abilities that you have within secure web gateways. So we can create selective policies that can decide what is the level of security that you want to employ. So here we have our own categorization engine, and you can see that we have all the different categories that you can expect from a secure web gateway, and you can create a policy that doesn't only enforces the security aspects and prevents malware and phishing, but also the compliance and liability of preventing access to sites that relate to compliance, productivity, and others. So all of this is part of the Fireglass product. All of the user enforcement is available through different profiles that can be used as part of this policy. So we have profiles for isolation, we have profiles for controlling the download and upload of a behavior of the file, and we can make here specific decisions for specific file types. You can see here, for example, that we can decide that PDF files will be viewed through our document escalations, but if executable files, you can just say that you want to block. So you have full richness of making that decision, and we also have the ability to control what users are able to do with specific websites. Sometimes there are applications that you want to introduce another layer of hardening into that application, and with Fireglass you can control things like clipboard operations, like copy and paste, like saving images, saving links, preventing print, and even allowing the remote usage of developer tools in the cases where you have a population that needs to access the developer tools to access the actual code of the website, but to do it in a very safe way. So there is a very rich policy that can do anything that you normally do with a normal web gateway and more. So let's go back and talk about now on let's go back to the presentation. And let's talk about the use cases for the solution. Just trying to move the slide here. Okay, so let's talk now on what are the common use cases and why would you want to use Fireglass. So the first one and the most obvious is, of course, providing true isolation, as I showed, against all malware and in phishing and drive-by infections and so on. The other one is to extend and augment secure web gateways by allowing safe access to uncategorized and risky websites. This could be things like private Gmails, file sharing applications like Box and Dropbox, and other things that normally will be blocked in the policy. Now you have the alternative to provide them as isolated, and doing it with working with the same web proxy that we're using, just modifying its policy to forward some of the traffic to Fireglass. Third use case is to protect against emails. The same technology is also available for email, and it works much the same. It takes the web links that are coming through email, and it takes attachments, and when the user click on these links or attachments, they're opened through the Fireglass isolation platform, and they are protected. Fireglass also have specific features that are preventing phishing attacks, and they are controlling if users are posting sensitive data like passwords or credit card numbers and social security numbers into websites that are not secure. Next one is, as I showed, allowing access to documents without downloading them and executing them locally. This could be done for PDF documents and for Office documents. And finally, we provide the ability to do virtual patching of plugins like Java and Flash, and even to remove them completely from the endpoints. You can disable Java and you can disable Flash, but still when you browse through Fireglass, because Fireglass will do the rendering of this remotely, you will still able to experience these websites, but without really having to execute them locally. Move on. So let's move on to the next slide. So let's take a few questions from the audience. Any questions? I encourage you to visit the Fireglass website and learn more about the solution and contact us. You got here our contact details through email and Twitter, and we will be happy to provide more information on our solution and see how it could fit and answer your security concerns. So thank you for joining the webinar today, and I hope that we were able to clarify why existing secure web gateways today are not really delivering the promise of security, and they're not really effective in preventing malware and phishing, but that there is a new alternative with Fireglass, with the concept of isolation that can solve these problems. So I'm going to wait just a few more seconds if there are any more, to see if there's any questions. No questions. So thank you very much for joining me today, and I'll see you very soon in another one of our webinars. Thank you.